Welcome to The Explainer. Our goal here is pretty simple. We take these big, complex stories and break them down into clear, easy-to-understand narratives.
That's a pretty heavy warning, right? And it comes from Albert Einstein. Now, we all know his name. It's basically a synonym for genius. But his real story? It's so much more complex and fascinating than just one famous equation.
So, how did the guy who literally redefined reality end up regretting his most famous discovery? Well, that's what we're going to unpack. Let's dive into the three acts of his absolutely incredible and, pretty conflicted legacy.
All right, Act 1. And our story starts, well, not in some grand university lecture hall, but in a quiet Swiss patent office. And this wasn't really by choice. Einstein had this rebellious streak from a young age. He just couldn't stand rigid, authoritarian teaching. In fact, one of his teachers back in Munich famously told him to leave, saying, "Your mere presence spoils the respect of the class for me." So with that kind of nonconformist spirit, he couldn't land an academic job. And that's how he ended up as a humble patent clerk who was about to completely rewrite the laws of physics.
So get this, in 1905, what we now call his miracle year, or Annus Mirabilis, Einstein drops 4 papers that just change everything. We're talking about laying the foundation for quantum theory, giving us the first real proof that atoms even exist, and introducing the entire world to this bizarre new concept called special relativity, all in a few months.
Now, special relativity is built on 2 ideas that sound kind of simple, right? But trust me, their consequences are anything but. If the speed of light is the universe's ultimate speed limit for everyone, no matter how fast you're moving, then something else has to give. And that something is space and time. They're not fixed, they're flexible. This leads to some really mind-bending stuff, like time actually slowing down for a moving object, that's time dilation, and objects physically shrinking in their direction of motion. Wild.
And out of all that came this, arguably the most famous equation in history. What's crazy is that it was almost just a little add-on, a footnote to his paper on relativity, but inside that simple little formula was, well, a universe of power.
So what does it actually mean? Well, the crucial takeaway here is that even a tiny, tiny amount of mass is hiding a colossal amount of energy. They're not separate things, mass and energy. They're 2 sides of the same coin. And that c² part, the speed of light squared, that's just the conversion factor. And it is a huge number, which is why the energy released is so immense.
Okay, so fast forward about a decade. Einstein isn't done. He expands on all this and gives us his absolute masterpiece, the general theory of relativity. And this is where he tells us that gravity isn't some mysterious force pulling things together. Nope, it's the actual curvature of space-time itself. Just brilliant. But it's the power hidden inside that earlier, simpler equation that's about to escape the blackboard and enter the real world, with truly terrifying consequences.
And that brings us to Act 2. This is where we see how Einstein's incredible theoretical breakthrough ends up leading to the single greatest regret of his entire life. You have to understand, Einstein was a lifelong, deeply committed pacifist. He absolutely hated militarism. He publicly argued that the only way to truly end war was for people to just refuse to fight. He was convinced that real peace could only come from total disarmament.
But then comes 1939, and this deeply held belief, it's about to be put to the ultimate test. A fellow physicist, Leo Szilard, comes to him with some terrifying news. He and other scientists, many of them refugees from Europe, had heard that Nazi Germany might be trying to build an atomic bomb. And Szilard knew the only person with enough influence to get the President of the United States to listen was Albert Einstein. So think about the choice he had to make. His lifelong pacifism on one side, and the terrifying possibility of Hitler getting a nuclear weapon first on the other. He made a choice. He signed the letter. And that letter, which warned of these extremely powerful bombs of a new type, urged the president to kickstart American research. It basically set the wheels in motion for what would become the Manhattan Project.
And then, the bombs were used on Japan. Einstein was apparently just filled with this profound sense of remorse. He said later that if he'd known the Germans wouldn't succeed in building a bomb, he would have done nothing. It was a mistake, he said, a burden that he carried with him for the rest of his life.
So, for our final act, we see this incredible twist. The man who was the ultimate scientific revolutionary, well, he becomes an outsider, almost totally isolated from the very field he helped create.
It all came down to quantum mechanics, a theory his own work had actually helped launch, but he could just never accept its core ideas.
The thought that the universe, at its most fundamental level, was governed by probability and pure chance, it just deeply, deeply troubled him.
So you have these two competing views of the cosmos. On one hand, you've got his general relativity. It's predictable, it's elegant, it's geometric. On the other, you have quantum mechanics, which is all about probability and uncertainty. He just rejected this new physics of uncertainty. He held on to his vision of an orderly, knowable universe, even as pretty much the entire physics community embraced the strange, weird, but incredibly successful world of quantum.
So what did he do? Instead of joining them, he poured all of his energy into this lonely quest for what he called a unified field theory, basically a theory of everything. He was searching for one single elegant framework that could unite all the forces of nature without all that messy quantum uncertainty. It was a goal that pretty much consumed the last 30 years of his life.
But the quest just wasn't successful. For one, he was working with an incomplete picture of the universe. Some key forces of nature hadn't even been discovered yet. But maybe more importantly, his refusal to accept quantum mechanics meant he was essentially trying to solve this giant cosmic puzzle while ignoring one of the most important pieces. And this really left him intellectually isolated from the rest of the physics world.
So, what's the takeaway here? Was that final 30-year quest a failure? Well, maybe. His lonely search didn't succeed. But here's the thing. In failing, he perfectly defined the central, most challenging problem that physicists are still grappling with today. How do you unite his beautiful theory of gravity with the weird world of quantum mechanics? In the end, his legacy isn't just about the answers he gave us. It's also about the profound, brilliant questions he left behind.